Hello everyone and welcome back. So continuing on with the VertexCache, in this video Lee's going to be implementing the remove and the release hold methods.
Right. Now, there's going to be two of each, so they're going to be or overloaded.
Overloaded.
Yeah. So, but I was going to say overridden. No, that's not right. Overloaded. But basically, what's the difference between the two is the fact that one of the methods will remove or release the hold on a single vertex, while the other overload will take in a list of vertices to be removed and operate on a list of them.
Okay.
So let's start off with the hold because that is the easier of the two. So I'm going to drop this in, well, here, let me close all this stuff up, and I'm going to drop these right underneath add neighbor. So we'll start with release hold. The first overload that I'm going to deal with is the one that will release the hold on a single vertex. So this will be release hold. It will take in a vector2 position. And to release a hold, it will check to see if that vertice is there. Whoops. So contains key position. So if it finds it, it will take that vertice with element of position and set its hold to false. Now, the second overload of this is, I need to make this static too. And I'll just copy that part. Save me some typing, because I like being lazy when I can. The second one is going to take in a list of type vertex, and I will just call this verts for now. Then it will simply iterate through the entire list, and for each vertex in the list verts, it will release the hold of them, calling the other overload. And to do that, we'll call on that vertex's key, which is the vector2 variant of its position, which is why it's called key. Get rid of that, clean that up. Those are our two release holds. Now, let's work on remove. We'll do it in the same way. We'll worry about our first remove, which will just work on a single vertex, and then we'll worry about the one that is for a list. I'm going to copy the code for the first one, change this to remove. Now this is going to work slightly different in the fact that this is just setting a flag. So the first overload, the one that works on a single vertex, is really going to remove that vertex from the list. So I don't need to do a check to see if it's there, because remove will not do anything if it doesn't exist. So I can just call vertex remove and send it its position. So that will handle that part of it. Now the second overload, the one that deals with a list, is going to be a little bit more complicated. Not too bad, but just a little bit more involved. So this will take in a list of vertices, and then I will call this again verts. So what we're going to do here is loop through each one. So for each vertex in the list verts, we're going to have a try catch. So what we're going to do is if vertices.contains key, so we're going to check to see if it's there. So we're going to look at the vertex key, just like we did before, and vertices vertex.key hold or not vertices. So we're going to check to make sure hold is not
Not
true,
true. Mm-hmm.
and not vertices vertex.key. So we need to check if it's not modified. So we need to deal with the condition if it's not being held and it hasn't been modified, we can go ahead and flag it for removal. But if for some reason it's been modified or held, well, if it's in hold, it's not going to remove it at all. And right now, I have no code for dealing with it if it's been modified. We will have to come back when we have the persistence code and the data store in place and deal with the condition of what are we going to do with these vertices if they've been modified. So we're going to have to save those out before they get removed. So if we meet all those conditions, meaning we're able to remove those particular vertices, we're going to go ahead and set that particular vertex destroy me flag to true. We don't really want to go through here and destroy these right now. We're just going to flag them saying, hey, the next time the purge thread comes through here and everything's okay, we can go ahead and remove this. And the reason I'm putting this in a try catch is the fact that there have been cases where when I was dealing with the threading stuff, the thread and this have collided, even with the locks, and I found that if I just deal with the try and the catch, if for some reason the list has been modified, it will continue to work and it will pick up on the next round. Because we're just dealing with flags at this point, so for whatever reason, if it's not possible, then these flags should be checked later. And then here, we get rid of the throw. So we just do a regular catch. So it's just kind of a fail-safe to get us through here. So that will deal with our single remove, and this will deal with our list remove.
Okay.
And both of our releases are taken care of.
Okay. Well,
That's it
yeah.
for this.
All right, beautiful. All right, well, with that, that's going to wrap up this video. Thanks a lot, everyone.